Alright, tonight's video is going to look at earthquakes and seismic waves. We're going to define what an earthquake is and then the three types of vibrations or seismic waves that an earthquake can create. So what is an earthquake? We define an earthquake as the shaking and trembling that results from movement along a fault. So it's the shaking and trembling that we'll see on the Earth's surface or underground as the two parts of a fault move past each other. And we can get this at any type of fault. We can get it at a normal fault, a reverse fault, or a strike slip fault. As those move, they will release energy as an earthquake. And so earthquakes happen when stress increases along a fault over time. And eventually that rock will break. Right? In a few seconds, that earthquake will release all the energy that was stored. So imagine thinking about the popsicle sticks from the lab today. As you bent and bent and bent, that popsicle stick was storing energy, and then all of a sudden it snapped. Same thing will happen with the Earth. Right? And so we have two places that we define as locations that are important for an earthquake. So we can say where earthquakes happen. The focus is the area underground beneath the Earth's surface. And so this is where the actual earthquake starts, is at the focus. Right, so this diagonal line here represents a fault. The focus is where the earthquake happens. Right? And I remember that a focus is underground because focus has a U in it. So focus has a U for underground. And if I were to trace a line straight up, the point on the Earth's surface directly above the focus is called the epicenter. So this is where the effects of the earthquake are going to be the strongest because it's the closest point to the focus. As you go farther away, the energy will have longer to reach there and it will spread out, so it won't be quite as strong. So when an earthquake happens, this energy gets released in what are called seismic waves. And a seismic wave is just a vibration that travels through the Earth and across the Earth's surface, carrying energy released during an earthquake. Right? Think of like ripples in a pond. You throw a rock into a pond, that energy gets released outwards across the pond surface. Right? Same idea. The seismic waves are carrying the energy away from the focus of the earthquake. And there are three types. We've got what are called P waves, S waves, and surface waves. And we're going to look at each one individually. So our first type are called P waves or primary waves. It's primary, or what are called P waves. Right, these are the first waves to arrive from an earthquake. Right? They move the fastest through the Earth, and they compress and expand the ground like an accordion. Right? So as the wave moves by, it causes the ground to rotate back and forth. And the way I remember this is that P waves push and pull the ground. So P waves push and pull. And we'll do a little lab tomorrow in class to demonstrate this motion. P waves, importantly, can travel through solid and liquid. So a P wave can travel through the crust, through the mantle, but can also travel through the outer core as well as the inner core. So a P wave on one side of the Earth could travel all the way through the Earth to the other side. These don't do a lot of damage because they tend not to be very strong, but they do move very fast. Our next type is S wave, which stands for secondary waves. Secondary or S waves. Secondary. There we go. All right, they arrive second after the P waves. These cause more damage. They vibrate side to side or up and down. So S waves are side to side, like an S motion. Right? And so as the S wave moves by, it moves the ground up and down or side to side. But these can only travel through solids. Right? Liquids can be compressed and expanded, but if you try to shake a liquid side to side, it just kind of sloshes and it won't carry the vibration through it. So S waves, crucially, cannot go through the outer core. And this is actually how we figured out that the outer core was a liquid, because we noticed that S waves from an earthquake didn't make it all the way to the other side of the Earth. Only P waves did. So that's how we figured out there had to be some liquid in the way. So S waves can only go through solids. They cannot go through liquids. And then our last type of wave is surface waves. Right? Surface waves happen when P or S waves hit the Earth's surface and interact. And since they can't go up anymore, they tend to move onwards in a rolling motion. right? So they don't have an abbreviation. We just call them surface waves. And they move along the Earth's surface kind of rolling like an ocean wave for the most part. They move much more slowly, but they cause the most damage. All right, so kind of a way to think about it is imagine you're in the room that you're in. If you were to take a big barrel and put it under the floorboard somehow, and then roll that barrel along, and so the floor has to like move over that barrel as the barrel rolls by. You can imagine that's going to do a lot of damage as it moves through the room, and the floor has to move up and out of the barrel's way. So there's going to be a lot of damage as this surface wave rolls by. And last thing is, since these all go at different speeds, so last thing, location of earthquakes, and we don't have a slide for this, but I'll just explain it quickly. Since different waves go at different speeds, if you can figure out the time difference between a P wave and an S wave at a certain location, you can figure out how far away the earthquake was. And if you know this from a couple different spots, you can pinpoint the exact focus of the earthquake. And so that's how we figure out where the earthquake happened, by looking at the time difference between P waves and S waves arriving. The longer the difference in time, the farther away the earthquake was. All right, that is all your notes for tonight. 3 questions at the end. We will look at this in class tomorrow and play with some slinkies to demonstrate these different types of waves.